Euler's transformation for hypergeometric function. So basically, in my previous videos of the hypergeometric function playlist attached over here, we have already discussed the definition, integral representation, and how to change Taylor series to hypergeometric function, and Pfaff transformation, and now it's time for Euler's transformation. And I will just give you some glimpse of what we have learned till now, a short glimpse, and then we will begin. So basically, the hypergeometric function sum definition, for a b semicolon c semicolon z. This is sum going from n equals to 0 to infinity, rising factorial of a, rising factorial of b by rising factorial of c, z to the power n by n factorial, where rising factorial of k means k plus 1, this product up to k plus n minus 1, and the integral representation for this was hypergeometric function for a b c z. This was equal to 1 by beta of c minus b comma b, integral from 0 to 1 of t to the power b minus 1, 1 minus t to the power c minus b minus 1, and 1 minus tz to the power minus a dt. Using the integral representation, we found out the Pfaff transformation, and that was hypergeometric function a b c d z. This is also equal to, there are two forms. One of them where there's a over here in power, and other where there's b in the power, and this times hypergeometric function. If there's a in the power, we write c minus b, and if there's b in the power, we write c minus a over here. Okay, so these things have been discussed till now. Now it's time for the Euler's transformation, which states that 2f1. And I made a mistake over here. This is not z, this is g by g minus 1. G by g minus 1. I'm sorry for that. Okay, so now this is Euler transformation. So 2f1 a b c g, this is actually equals to 1 minus g c minus a minus b by 2f1 c minus a c minus b c g. Okay, now we use Pfaff transformation twice in this function, and we will get the result. Let's see how. So if we apply for b, so we get 1 minus g to the power, let's say we get minus b, and then 2f1, we get now c minus a b, and then c, and then we get over here we will have g by g minus 1. And if we apply Pfaff transformation once again, for this c minus 1, what do we get? So 1 minus g to the power minus b. Okay, so now again we will use this thing over here. So we get 1 minus, basically now the variable is g by g minus 1. And now again, if we use c minus 1, just like we previously used b, now let's use c minus 1, c minus a, sorry. And in that case, if we use b, then over here in a we had c minus a. So now over here in b we will have c minus b. So 2f1 c minus a c minus b. Basically, one of the variable will be used here, and other will be c minus a. Again, this variable was used here, and other will be c minus b. So that's the case. See, and over here, g will substituted by g minus 1. So we'll have g by g minus 1 by g by g minus 1 minus 1. Yeah. Now let us say what this is equal to. 1 minus g to the power minus b. Now this is just minus 1 by g minus 1, and then minus c plus a. So 2f1, this is c minus a, c minus b, c. Now this is just g by g minus 1 by 1 by g minus 1. So that's just g. Yeah. And now this is 1 minus g to the power minus b. Now this is also 1 by 1 minus g, so we can write this as 1 minus g to the power c minus a. Yeah. And then 2f1, c minus a, c minus b, c, g. Now we can merge these two to get 1 minus g to the power c minus a minus b, or 2f1, c minus a, c minus b, c, g. So here we prove the Euler's transformation of hypergeometric function. Yeah. So we basically get 1 minus g to the power c minus a minus b, 2f1 c minus b c times z. So what did we do is we basically applied Pfaff transformation twice, and that gave us the result. So that was it. Thanks for watching. Look forward to seeing you in the upcoming videos too.